Okay, so let's start by introducing what this course is about. So what is this course about? In this course, we have this long paragraph of students will be acquainted with the fundamental and the implementation of cloud computing, etc. But fundamentally, it's about data engineering in Azure. So it's about how you do all the regular data engineering tasks utilizing the services provided by Microsoft Azure. So what is data engineering? We should start with this question. Data engineering is a field within data management that focuses on the practical application of data collection and data processing. So data collection and data processing, these are the two key elements of the two key tasks of data engineering. It involves designing, building, and maintaining the architecture, both hardware and software, and the systems that allow organizations to collect, store, and analyze data efficiently. So we talked about collection, processing, which sometimes is called extraction and the transformation, and then you will store it somewhere and save it for later analysis. Right? In common data engineering architecture, everything starts with the source. You have the source. Sometimes it's a business enterprise application like a CRM, customer relationship management. Sometimes it's a third-party data. You collect the data from someone, like a government agency or some nonprofit organization. Then there's also data from customer, which can be social media. All these data will be moved into a storage. Sometimes it's called data lake, sometimes it's with other names. Then you will perform your extraction, transformation, and loading task, commonly called ETL, moving this into a data warehouse. Then within the data warehouse, someone will consume that data by reading, querying the data inside it. And sometimes you will do even more in processing. You will aggregate it differently so that it can be even consumed by others. A lot of times it shows up as a dashboard. Sometimes it shows up as a data visualization. All these are possible use cases for the data you collected, loaded, and transformed. So if you think about how you will do a data engineering job, let's think about how you will set up your data engineering, set up a data engineering job on your laptop. For example, if you want to calculate your own monthly spending, what do you need to do? First of all, you need to have the data sources. You either take out the paper statement and manually type in the data into your Excel spreadsheet, or sometimes you can you get an email attachment of Excel from someone like your CPA, or sometimes you can go to your a bank web page and download your account information. This is how you collect data sources. And usually this end up as files on your machine, on your laptop. Then once you get all these source data, you will start your processing. You will open up your Jupyter notebook, your Excel, or your notepad, going through different statements, extracting useful information. If you have a bank account, for example, you probably, for this purpose, you probably don't care what account number is. Maybe you are interested in the account type, whether the money goes from your checking or saving or credit card. But you are probably not going to be interested in knowing whether this is what account number it is, right? So you will remove the account number information. But then you're probably interested in knowing whether it's a weekend of your spending. So you will add additional information based on the date. These are all processings or transformations that may happen. Then finally, you finish listing your data and you finish the categorizing your data and get some meaningful inclusion. Like every weekend, I'm spending some money on ice creams, which I probably want to reduce. These are the analysis you perform, and these are the results you get. and you want to save that, right? You have the information collected in your Excel spreadsheet, for example. You will manually upload it to online storage or save that to your hard drive and save it to a USB drive, depending on what you want. So here you have a source, you have a processing power, and you have a target. That's the components of every data engineering job, just that this simple job is happening on your laptop. Now, if you think about what is utilized here, your laptop definitely have a compute power, which consists of a CPU and memory. A CPU will perform all the necessary tasks, and the memory will hold temporary data like your Excel or your web browser. Then once you finish downloading, and you will save your files into a storage like hard drive. Then once you finish your analysis, you will store your result into hard drive too. So this is the storage that we will need. And apparently, in order to go to your bank account website, in order to get email, you will need internet connectivity, which basically is a mini network inside your home. And finally, on your laptop, you will need your operating systems and applications in order to perform all tasks you just performed. The operating system may be OS or iOS, maybe Windows or iOS. And you will have Excel or web browser in order to get the information and analyze the data, right? So if you look at a corporate world, the data engineering in corporate world are not much different. They also consist all these steps, all these components. The difference is just that they do not do one thing do everything in one machine. Instead, there are multiple servers involved in most of the engineering tasks, data engineering tasks. It's a servers. Different servers have their different separated duty. Some servers may be the transactional application server, which generates the original data, right? And for example, the transactions, the sales of a web of a e-commerce company, or the user post handling server of a social network company. These transactional application servers generates the source data that you want to use. All these data will be saved either to a file server or to a database server, depending on how they were set up. This temporarily intermediate storage eventually will be picked up by some analytical application servers, which does the same processing you would like to do, like removing unnecessary fields, deriving useful information, aggregation, and coming up with a hypothesis and coming up with solution suggestions. All these are done by those analytical application servers. And finally, these servers are connected through a network of network cables. And with routers, switches, they are able to connecting to the internet. And all of these server has some sort of operating system and application. So as you can see, all these components are and their duty are not that much different from the little example we just discussed, that you're performing a monthly spending calculation on your laptop, right? Just that they are bigger, and because the task itself is bigger, so the servers has to be bigger, and the servers has to separate from each other so that they can focus in only on one thing, so that they can perform the duties better. Now, we already said everything is done on a server, right? Traditionally, companies host servers in the same office as employees. You will see people, some engineers have a server under their desk, or just right at the corner. And these servers are not much different from the traditional desktops that you will have in your workspace, just larger. Usually they are larger and they are louder because they have a more processing, so it emits more heat than normal desktops. But the issue with this approach is that the requirements for a machine, for office hosting machines, are very different from requirements for offices that hosting human beings. So first of all, physical access. If it's a machine office saved for regular human office, you would like it to have a better access, more roads, open, more parking space, and it's easier to go anywhere on the floor. However, if it's a server, you want servers to be stable. You want the servers to be packed together all neatly and in a particular order. You don't want everybody to come to be able to come to this office and touch the servers. You want some kind of isolation from human being. So this is the two completely different requirements that's actually against each other. And also, servers generate a lot of noise and heat. So, and human beings certainly doesn't like this noise, right? So the solution of a traditional company is that they will have a own office, putting server there just for the servers. Those offices are usually in very remote place, and all it does is collecting all the servers used by that corporate, so that you can connect this to the human office, so that human beings can use that. So this is kind of office is usually called data center. Data center is a centralized facility designed to house and manage a large number of computer systems and associated components. So here, computer system basically means server. Associated components mostly mean storage and networking, right? You would place all your servers and their accessories into one building, and human users, will access these servers through a private network between offices from their human office into this data center, so that you can hide the IT work from end users. You can hide the machines away from users. IT can hide those machines safely in a place that's isolated. Nobody else can come to your nobody else outside of the IT team can get into this data center, so that they can have maximum security. Now, data center certainly is very useful, right? We have two pictures, and some of these are like from the 50s, and the one to the right are actually like a more modern one with all the rack servers. But there's also issues with data center. The number one issue with data center is it requires high cost, high investment upfront. Each data center at the very beginning, or at least even after it has been developed for a while, each data center can only serve a small number of customers. They can only because building a data center requires a specific consideration of land, of power, of networking, and security. And inside data center, there are so many servers. Cooling is a huge issue, and ventilation is a huge issue. So this requires special consideration, requires high investment. It's out of reach for smaller companies. Most data center early on can only serve a small number of customers. And once you build a brick and wall data center, its capacity is limited to how the size of building you build. You can only have that much servers hosted inside this data center. The capacity is predetermined and paid in advance. It's very inflexible. It's hard to change, right? If there's new requirement, let's say your company doubled its size, then the data center can no longer meet your requirement. And also because the data center usually is reserved only is only used by a small number of customers, you can easily see there are peak and trough in the usage pattern. Every morning at 8:30 or 9 o'clock, people coming in, open up their laptop or the desktop, then suddenly you see a huge increase in activity. Whereas at night, 12 p.m., 12 a.m., everybody left or everybody sleeping, nobody's using that machines. The machines are sitting there idle. It's a complete waste out of resources at night versus where likely you will have a lot of capacity issue and performance issue during peak hours. So people talking about scaling up and scaling down. At certain times of the day, at certain times of a year, there are more usage than other times. For example, if you are doing retail, you all know that the holiday season during holiday season the spending will be much higher, and the transaction you will have much more transactions. But if you already get the data center set up there, you only have that much amount of servers. It's difficult for you to adjust to this up and down in usage. The next issue with data center is that it's centralized, right? We mentioned why do we want to put them into one machine, all the machines into one building? Because it's easier for maintenance. All the machines can be hired together. You have the same facility taking care of their needs, cooling needs, ventilation needs, and repair needs, networking needs. But on the other hand, centralized facility is vulnerable to disasters. What if there's like a natural disaster, hurricane or earthquake coming? What if there are human errors, fire, or even terrorist attacks? Right? All these are possible, and they are vulnerable to disaster. A few years ago, one of the largest data center in Europe actually caught a fire. As a result, like thousands of websites was out of service. And finally, one issue that may not be so apparent to engineers is that a lot of companies, they are not IT companies, but because they need to maintain a data center, they have to maintain an IT team. Let's apparently this is not their core business value, right? If you are a company selling pharmaceutical drugs, or if you are a company selling clothing, you are not in the IT business. Maintaining the data center is definitely not your core business value. We also always use the analogy that do you need to keep electrician in your house every day? You don't even want to keep them even during the Christmas time, right? When when you set up all the Christmas lightings, right? Let alone like regularly every day. Not like that. So what you would like to have is to have focusing on your core activity, not on this IT data center maintenance thing. And that's all these issues. High investment, capacity, predetermined capacity, peak and trough usage, centralized disaster vulnerable, and not focusing on core business value. These are the reasons that cloud computing come into being. The beginning of computing actually starts with Amazon. As you can see, Amazon is a huge company with a vast amount of transactions, right? To handle those transactions, it also built a vast amount of resources like computers. But just like what we discussed, for retail business, the peak time comes at November, December. And for some other country, it may be earlier. For some other country, it may be later. Like I think some countries, the shopping comes in October, whereas like in the East Asian countries, the peak sellings comes in the Chinese New Year, which is usually in February, January and February. So somehow they are able to spread out a little bit, but still a lot of times there's a lot of waste of idling resource. So naturally it comes to Amazon that Amazon's leadership that can we sell the idling resource, compute resources to some other customers. That's the beginning of cloud computing. At the very beginning, it was just a regular data center service, just providing compute and storage to their customers. But then because of the size of Amazon, there are two things that comes to table. One is the size of Amazon brings cost down. As you have a huge fleet of the data center and you run the business as if it's happening to each and every data center the same way, it reduces cost. And the second, more important thing is you have a much larger size of users for for Amazon's data center. The size and diversity of users. There's a lot of users, and these users can be anywhere in the globe, across different businesses, having different usage pattern. So the size and diversity of users make the usage demand relatively stable. You always have somebody using something. So it evens out, basically, evens out across the different countries, across the whole globe. That allows a continuous real-time provisioning and termination of resources. Instead of worrying, do I need to build a new data center? Now Amazon can pretty much estimate, oh, we have a relatively stable usage. When some customers exit and stop using their resource, there are always some new customers coming in and requesting the same. So even though we do need to gradually increase our capacity as business grow, there's a much better chance that in the short term the sales is stable, the usage is stable, so that we can do a real-time provisioning and termination instead of waiting for a new data center to be built. So that's when a new paradigm of on-demand IT service emerge. That brings that on-demand word, the term on-demand brings us to the definition of cloud computing. What is cloud computing? Some characteristics of cloud computing. Number one is the on-demand provision of IT service or IT resource. You ask for it, you get it. Then the second thing is pay as you go. I provision a server, I run it. Once I finish, I close that. I'm not going to pay for it. I only pay when I use the server. Once I stop using the server, I'm not paying for it. Comparing to what the traditional data center, you build a data center, it's there, the servers are there. Even if you are not using that, you already paid upfront. You are still paying for its for for its usage or storage or everything or the electricity. So, but in cloud computing, you pay as you go. You provision a server, runs it, and once you finish, you stop. You don't need to pay, and you can do that because of the huge user pool, because of the diversity in the user profile. So when you stop using, there's always someone will coming in and take over that resource, request the same resource and run that resource so that he's paying or she's paying. So Amazon can have a steady income that evens out the cost of maintaining the server, the data center, and everything. So on demand provisioning, pay as you go, that's the key element of cloud computing. And the other thing that is mostly common is usage over internet. Sometimes this is not entirely true for the whole cloud computing world because there are some company or government agency that really cares about their security, so they will do this through private network. But for the most part of a commercial usage, yes, the usage of cloud computing is over internet instead of the dedicated network between a data center and the companies the office. So these three are the key elements of cloud computing. Comparing we usually use the analog of electricity supply. At one point, every building in Lower Manhattan had its own generator generating electricity for the building. But eventually, this power generator phased out. Everybody starts to use the public utility, which supplies electricity to each building. And you think about electricity supply. Whenever you need to turn on the light, you turn the switch, light the light turns on. And when you don't need it, you turn it off. You stop paying for the power, the electricity you pay, and it's delivered over a public electricity grid. Isn't it the same as the cloud computing? So here comes the official definition of cloud computing. The U.S. National Institute of Standard and Technology, or NIST, defines cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool. Look here, shared pool of configurable computing resources. For example, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. So you can basically what it says is can get provision on demand and end it with minimum management effort. So this is the official definition of cloud computing. So now that we know what is cloud computing, let's talk about the advantage of cloud computing. We already mentioned something before. We mentioned what is not ideal in the data center world, and we compared cloud computing somehow to data center a little bit. But now let's talk about this in a more formal fashion. There are many things that you can, many advantages that you can claim from the cloud computing side. But officially, there are 5 advantages that people talk the most often about cloud computing. So scalability, elasticity, agility, high availability and disaster recovery, security, and cost saving. We'll talk about them one by one. So the first thing we want to talk about is scalability and the elasticity, which I believe you already have a sense, right? We talked about data centers are pre-built with a predetermined capacity, while cloud computing, because of the size of cloud computing providers, huge, gigantic companies like Amazon and Microsoft and Google, they have a much larger utility resource pool, and they have a much larger user pool. So demand can go up and down. Nightly processing is nightly. Usually, you have a much less usage at night, and then by date in the year, you usually have high demand in holiday season, and suddenly there are like sudden changes coming in. You never know when, right? Pandemic teaches us a good lesson, like those online conferencing companies. They never expect their business will be booming like that. So things can change anytime, and nobody should be forced to predict the future. Maybe I should say nobody is capable of predicting the future. Instead, we should just be prepared, react, and respond. So here we have an example like on if you are looking at this usage versus time chart, green means the resource you have enough resource to process the usage, and red means of course over usage, right? If you are in the on-prem world where the capacity is predetermined, is that dashed line, then whenever your usage goes beyond that line, you are short of a resource. But whenever it goes down below that line, you're wasting resource. Whereas in the cloud on demand, you provision whatever you need. When your resource need is smaller, you can provision less. As your need increase, you can gradually increase the resources you provision until it start to fall down. Once it start falling down, then you can gradually remove terminate your provisioning, so that your provision is always a little bit higher than the actual demand. That gives you much more flexibility and ensures, one, your usage, your performance is always under control, and two, your cost is also under control because you are not over provisioning and wasting resources. And by the way, what is the difference between scalability and elasticity? This both means you can adjust your demand. So there are like different ways of defining how you would change your demand, change your provisioning, change the size of your resource based on demand. But scalability usually means going things up and down based on demand, where elasticity usually means in the long run uh, you have a more structural change. So the next thing we want to talk about is agility. Agility is the ability to adapt to the latest change in business flow quickly. Or what happened in the data center world is that because in a data center world, not only the hardwares are fixed, right? You build your building, you can only have that amount of servers. But not only that, usually the business software license are also pre-purchased. For example, database or certain enterprise software, you have to purchase the license first before your users can use them. And once you purchase, it's usually by year. A common enterprise software agreement comes regularly at 2 years, 3 year, at 3 year to 5 year. So it's very hard to change. At least it's hard to get a good deal. So, but so changing your implementation, changing the technology you use in the data center world is not as easy. But things change, right? Addition or removal of a business process happens all the time, and compliance requirements change all the time. These will bring in change in demand for IT capacity as well as the technology stacks. For example, just generative AI. When OpenAI, before OpenAI published its Chat GPT, who will imagine? Everybody is starting using some kind of GPU, right? But once it becomes apparent that everybody is talking about it, everybody start buying GPU, which pushes the stock price of Nvidia up to the roof. The other thing is probably less exciting, which is the regulation for healthcare transparency requires insurance companies to publish their existing data using JSON formatted RESTful API. Now, JSON formatted REST API is not new, but usually it's not in. But most insurance companies rely on a much older technology, so they may not be able to handle this JSON formatted resource API. But if you are in the DC data center world, it's very difficult to come up with new resources and new technology stacks quickly to adjust to these change. Buying a CPU, buying a GPU, for example, is out of reach for most data center. But if you are using a cloud provider, because of their pool, because of their size, they usually generally will have some power reserved that you can utilize at such a time of change. The next thing we want to talk about, the third advantage of cloud computing is high availability and disaster recovery. Any physical hardware can fail. If you are limiting yourself to a data center with to the servers that the pre-installed in the data center, inevitably one of them will fail. That's inevitable even for cloud computing vendors. Their hardware will fail. But the distributed and on-demand nature of cloud computing can help in mitigating the issue, the availability issue. Cloud computing, cloud vendors generally offers redundant resources because they have a much larger resource pool. They also can offer the services like remote backup. Like it's difficult for you to do for a regular company to do backup in one place and save it somewhere. But it's not difficult for companies like Amazon or Microsoft or Google between their data centers, because this is basically already what it's already what they are doing day in and day out for their own business. So remote backup, continuous monitoring, and automatically responding, fail over to new machines, automatically fail over and automatically fail site and region. If a data center fail, can the vendor automatically fail over to other sites, other data centers for you? Or you need to provision new machines there. Most companies, most cloud, I should say the largest cloud service vendors, they can do this automatic for most of the services. That's another advantage of cloud computing. And similarly, um, we want to talk about the advantage of security of cloud computing. Security is a complex topic. We all know that. It requires expertise from different fields in technology, and it requires constant monitoring and management. So there are two things. One, you have to know it very well. Security is something that you need to know it very well to the level that only a few experts know in the world. And also you need to constantly monitoring and managing those. You need to constantly check something if something is happening. Most companies have limited resources to cover all aspects of security, but if you are relying on cloud computing companies, the service providers can afford to establish a wide range of security measures and offer them to all their clients regardless of the client size. And cloud service providers can provide a fast response to security vulnerabilities. For example, a few years ago, there was this Log4j vulnerability, which requires companies to identify what servers are affected and apply patch in large scale. The first thing already make a lot of people confused. Like it is because Log4j is used in a lot of Linux machines, but not all. So a lot of people start to wonder, do am I got impacted by this issue? But for cloud computing companies, they have a strong IT team, they have a dedicated IT team, and they were able to find out most of, if not all, of the versions of operating system that got impacted, and they are able to help their customers to apply patch in a large scale. And finally, the last advantage we want to talk about in cloud computing, of course, is the cost saving, right? It's basically an economy of scale. Cloud computing is definitely more efficient, provides more tools, and it's it allows you because basically the cloud vendors are running the IT work. So it allows you to more focus on your core business process instead of worrying different IT operations. If you have ever worked in the IT operation world, you will know that IT operations a lot of times includes a boring backups and monitoring, and all this can be taken care of by cloud vendors. And so, cloud computing mindset. As we talked about this before, cloud computing comes up with on-demand and the pay-as-you-go approach. The resources here are expendable. You can easily throw away a resource and pick that up, pick a similar resource again. Whereas in the traditional data center world, once you install the server, it's your pet. You have to take care of them. If you don't take care of those servers in your data center, once it break, you have to fix that and reset up everything. Whereas in the cloud computing world, the resources you never know where they reside. You only know that these are compute resources you get from a cloud. So this is what we call immutable, expandable nature. You can easily find a new one to replace the existing resource in the cloud computing world. That brings some mindset change. The first one is what we call immutable deployment. Usually when you have a server, you have your laptop, you want to update, right? From time to time, you start updating your machine, your operating system, or your office suite. But in the cloud computing world, you are not supposed to do update. Every deployment is immutable. If there's a new version of operating system, what do you need to do? You need to create a new resource using the new operating system and discard the old one. So this is what we call a herding, um, pet herding mentality, right? You're herding a cattle. You are not taking care of your pets. Then the next mindset you want to have is to try often and fail early, because resources are easily available. So the most costly part is not in getting the resource, but in the time you spend. That's why you need to try. When you want to try often and you want to fail early. You want to try different things, and as soon as it reaches the point that you can tell whether it's a fail or success, then that's when your time's worth is coming, right? You want to try often, you want to fail earlier, and then you want to also imply infrastructure and security in layers. Traditionally, you want to do security because you don't have enough resource or time to handle infrastructure and safe security, like backups, like monitoring. So you have to focus your area in one place. But now that you have cloud services behind you, you can do it in layers, apply much more infrastructure support and security monitoring, security measures. And finally, you want to start with easy repetitive deployment in mind. You want to enforce automation. You want to enforce scalability. You want to make every time you do something, you want it to be repeatable, so that if you want to make yourself make your system larger, capable of handling more things. You want to use it in a scalable and automatical way. It can be easily reproduced across um, against much more resources, because resources are easy to get. So to save your time, you want to automate. You want to make the um, less. You want to spend less time in configuring them. You want to do that using automation. So because of this, cloud computing is really gaining its trend. I have listed some estimated growth published by Gartner, all the way till 2025. You can see that traditional data center is increasing, but not necessarily as fast as the cloud one. And this, you can even see that from all the job postings in LinkedIn. I think a few years, probably like 10 years ago, when I started with the cloud technology, there are not too much um, job openings. But these days, if you go to looking for data engineer job in LinkedIn, I think at least half of them are cloud related, right? So this is directly related to why you are here for this class, because data engineering in cloud is a very hot trend. All right.